everyone, this is Mrs. Snowbeck. Today we are going to do Unit 7 Notes 2, but before we get started, I wanted to do a quick review of 7.1. Can you name this circle? So there's the symbol, and then you use the center letter. So this would be circle R. Can you name a radius? Remember, a radius goes halfway across a circle, so you could use segment MR. You could also use segment AR. You could also use TR or HR. All four of those start at the center and go to the edge. Can you name a diameter? Well, diameters go all the way across the circle. So in this case, the diameter that's shown here is segment MH. Notice how on the radius and the diameter, I put that bar above the two letters. So MH is a diameter. And lastly, can you name a chord? So a good chord here would be segment AT. It goes from one part on the circle, one point on the circle, to another point on the circle. So segment AT. And it's okay to reverse the letters and call it TA. That's really the only chord here other than the diameter. Let's get started on 7.2. So first, we're going to talk about what is a central angle. Well, a central angle is an angle with its vertex at the center of a circle. An angle with its vertex at the center of a circle. And you might be thinking, like, what's a vertex? Well, it's like the corner of an angle. So if you look right here at what I just highlighted in pink, that is an angle. This angle right in here is a central angle. So an example of a central angle in this picture is angle ABC. Angle ABC is a central angle. Its vertex is this point right at the center of the circle. So the vertex is B. And next, can we talk about the sum of central angles? So think about angle 1, angle 2, angle 3. If I take all of those angles and add them together, can you guess what they will add up to? Can you guess what their sum is? They add up to 360 degrees. Have you ever heard of that? In one circle, it's 360 degrees. Maybe some of you snowboard. Can you do a 360? That would be one revolution. All right, so knowing that the sum of central angles is 360, let's see if we can solve for x, or find the value of x. So this angle plus this angle plus this angle should add up to 360. So if we take the two angles that were given and subtract from 360, we should get our answer. So 360, take out the 165 and also the 145. So I'm just going to grab my calculator, you guys, and I'm going to type in 360 minus 165 minus 145, enter, or equals. And when I do that, I get 50. When I subtract both of those from 360, I get 50. So x has to be 50 degrees. Will you now pause the video and try number 2 and see if you can figure out how many degrees are left for x? So I would do 360 and I would minus this one, which is 90. And I would also minus the 40, and I would also minus the 85. So you're going to minus all three of those out of there. And when you do that, you should get 145. So x is 145 degrees. Let's talk about minor arc, major arc, and semicircle. Think about car crashes. If you're in a minor car crash, a little fender bender, it's not a very big car crash. It's just a little dent perhaps in your bumper. But if you're in a major car crash, that's a big car crash. Maybe somebody even got injured. That'd be bad, right? So a minor arc is something small and a major arc is something big. So minor arcs, they are less than 180 degrees. And the way that you write an arc is, I would say this, the measure of arc AB. So you put M for measure, then you put two letters that are on the arc or at the ends of the arc, and then see that little curve above them? So what I just wrote is the measure of arc AB, and then I'm going to say equals X. So what that means is whatever this angle is, this arc has the same measure. If this is a 100-degree angle, this is a 100-degree arc. Okay? Let's try the next one, major arc. Major arcs are going to be more than 180 degrees. And to name a major arc, this means it's going to go more than halfway around the circle. So do you see the red arc there? Let me outline it in some more red. It's this part right here. That is a major arc. It goes more than halfway around the circle. And the way that you name that arc is you have to use three letters. So maybe I would start at A, go to D, and then finish at B. So I could say the measure of arc ADB and put that curve above it. Well, that's going to be 360 minus X, because whatever X is going to be this arc up here, and the whole circle has to be 360. So if you subtract whatever's left, you'll get your answer. Finally, let's talk about a semicircle. A semicircle goes exactly halfway around the circle, and it will equal 180 degrees. So I'm just going to say that equals 180 degrees. So in this case, there would technically be two semicircles, but let's say I wanted to name the red one. If I want to name the red one, I'm going to want to use the three letters. I would say the measure of arc ADB. And if I include that D, you know I'm going around the top part of that circle through the D. That will equal 180 degrees. So we have minor arcs, major arcs, and semicircles. Number 3, GJ is a diameter of circle K. Identify each arc as major arc, minor arc, or semicircle, and then find each measure. Part A. Find the measure of arc GH. You guys, arc GH is right here on this red part. Look at the angle that opens up to that arc. The angle is 122, so the arc is 122. So arc GH is 122 degrees. Now, is that a major arc, a minor arc, or a semicircle? Well, it's less than 180, so it is a minor arc. Part B. Let's talk about arc GLH. Now, arc GLH, I'll use yellow this time. I got to start at G, then next go through L, and then wind up at H. It looks to me that I'm going more than halfway around my circle. In fact, it looks like I'm going all the way except for the 122. So what I would do on this one is I would do 360 minus the 122 and see what do you have left. Well, if you type that in your calculator, I think you'll get 238. So that yellow arc is 238 degrees. And is that a major arc, a minor arc, or a semicircle? It is a major arc. It is more than halfway around the circle. All right, last but not least, let's do the measure of arc GLJ. So I'm going to start at G. Next, I'm going to go through L. So I'm using green this time. So I'm going to go through green and then end at J. Now the green arc GLJ looks like it goes exactly halfway around. And you know what? I know for a fact it does, because you see how it starts and ends on the two ends of that diameter? That means it does go exactly halfway around. So this is going to be exactly 180 degrees, and it is known as a semicircle. So I'm going to have you guys try one. So will you pause the video and try number 4? Try all 4 parts, A, B, C, and D, and when you're done, unpause the video. So go ahead and pause. So the first one's sort of tricky, arc EF. That is this arc right up here. And it will be the same size as this angle right here. But how do we know what that angle is for sure? Well, what I thought about is this yellow line. That looks like a diameter. It looks like it cuts the circle in half. And so if I take that diameter and think, oh, that side of the circle is 180, so to get EF, I would do 180 minus that 60 that I see. So this whole thing is 180, and if I minus out this part, I should figure out that what's left is 120. So this angle is 120, so this arc is also 120. Arcs have the same measure as their central angle. And it doesn't say that we have to say major arc, minor arc, or semicircle, but this would be a minor arc. Let's do the next one, CD. This one's a little easier. So CD is this arc right here. Do you see how it opens up to this blue angle? How big is that angle? Well, since it has that box there, it is 90 degrees. So then our arc is also 90 degrees. So CD will be 90 degrees. That's going to be a minor arc because it's less than 180. Let's go to part C, arc CDE. Okay, so CDE has to start at C, go to D, go to E. So I have it here in green. Now that looks like less than halfway around. But if I use that yellow diameter, this side over here would be 180. But what if I can subtract the 52? If I subtract this 52 out here, won't I have the green arc left? That's what I would do, you guys. I would take the 180 minus 52, and I just typed that in my calculator, and I got 128. Again, another minor arc. And last but not least, we are supposed to find arc BDE. Well, I might need to erase a little here so you can see. But BDE, let me do it in green again. I'll start at B, and I have to go through D before I go to E. So I have to go B to D to E. Ooh, I think it's this green one right here. How big is that arc? Well, it's exactly halfway around. It's a semicircle. It is 180 degrees. Let's do that again. Pause the video again and go ahead and try number 5, all 3 parts. When you're done, unpause the video. All right, measure of arc AED. You can see I've kind of put some green pen mark there. And so we're going to figure out how big is that arc. Well, it's going to be the same as this angle plus this angle. So 63 plus 90. If I add those two together, because see the little 90-degree corner, I get 153 degrees. And that's how big arc AED would be. Part B, what about arc ADB? All right, let's see if I can get I'm going to do a highlighter this time. I'll do red. So I'm going to go from A to D to B. Now this one is interesting. The method that I decided to use is I cut the circle in half from B to E. See how there's a diameter there? And the right side would be 180 degrees. And then this other little part, so from B to E would be 180, and then this other little part would be 63. So if you add 180 plus the 63, you should get arc ADB. That becomes 243 degrees. And feel free to use your calculator, that's totally fine. Let's try part C. This time we need ABD. So I'm going to do a little erasing this time. I'm going to erase this. I'm going to erase this. I'm going to erase this even. And I'm just going to leave that green arc. Now remember that green arc, that was our very first question. And that green arc was 153 degrees because we added 63 and 90, okay? Now this time we want to find arc ABD. Let me highlight this. Let me use blue. So we're going to go from A to B to D. So do you see how around the circle is 360 and that blue arc, the one we want, is everything except the 153. And so here's what I would do. I would take the whole circle, 360, and I would subtract the 153 and see how much is left. And when you do 360 minus 153, you get 207. And so that blue arc would be 207 degrees. Great. Will you guys try Unit 7 Practice 2? If you need help, let me know. Have a great day.